From the fires of a sun's birth, twin planets emerged: Venus and Earth. Two roads diverged in our young solar system. Nature draped one world in the greens and blues of life, while enveloping the other in acid clouds, high heat, and volcanic flows. Why did Venus take such a disastrous turn? And what light can Earth's sister planet shed on the search for other worlds like our own? For as long as we have gazed upon the stars, they have offered few signs that somewhere out there are worlds as rich and diverse as our own. Recently, though, astronomers have found ways to see into the bright lights of nearby stars. They've been discovering planets at a rapid clip, using orbiting observatories like NASA's Kepler Space Telescope and an array of ground-based instruments. The count is almost 1,000 and rising. These alien worlds run the gamut, from great gas giants many times the size of our Jupiter, to rocky charred remnants that burned when their parent star exploded. Some have wild elliptical orbits, swinging far out into space, then diving into scorching stellar winds. Still others orbit so close to their parent stars that their surfaces are likely bathed in molten rock. Amid these hostile realms, a few bear tantalizing hints of water or ice, ingredients needed to nurture life as we know it. The race to find other Earths has raised anew the ancient question whether out in the folds of our galaxy, planets like our own are abundant and life commonplace, or whether Earth is a rare Garden of Eden in a barren universe. With so little direct evidence of these other worlds to go on, we have only the stories of planets within our own solar system to gauge the chances of finding another Earth. Consider, for example, a world that has long had the look and feel of a life-bearing planet. Except for the Moon, there's no brighter light in our night skies than the planet Venus, known as both the morning and the evening star. The ancient Romans named it for their goddess of beauty and love. In time, the master painters transformed this classical symbol into an erotic figure, then a courtesan. It was a scientist, Galileo Galilei, who demystified planet Venus, charting its phases as it moved around the sun, drawing it into the ranks of the other planets. With a similar size and weight, Venus became known as Earth's sister planet. But how Earth-like is it? The Russian scientist Mikhail Lomonosov caught a tantalizing hint in 1761. As Venus passed in front of the sun, he witnessed a hair-thin luminescence on its edge. Venus, he found, has an atmosphere. Later observations revealed a thick layer of clouds. Astronomers imagined they were made of water vapor, like those on Earth. Did they obscure stormy, wet conditions below? And did anyone, or anything, live there? The answer came aboard an unlikely messenger, an asteroid that crashed into Earth. That is, according to the classic sci-fi adventure, the first spaceship on Venus.
It was really a spaceship from another planet, which exploded in the air before landing.
A mysterious computer disk is found among the rubble.
Was offered access to the world's largest computer to try to decipher this strange language.
With anticipation rising on Earth, an international crew sets off to find out who sent it and why. What they find is a treacherous, toxic world. No wonder the Venusians want to switch planets. It was time to get serious about exploring our sister planet. NASA sent Mariner 2 to Venus in 1962, in the first ever close planetary encounter. Its instruments showed that Venus is nothing at all like Earth. Rather, it's extremely hot, with an atmosphere made up mostly of carbon dioxide. The data showed that Venus rotates very slowly, only once every 243 Earth days, and it goes in the opposite direction. American and Soviet scientists found out just how strange Venus is when they sent a series of landers down to take direct readings. Surface temperatures are almost 900 degrees Fahrenheit, hot enough to melt lead, with the air pressure 90 times higher than at sea level on Earth. The air is so thick that it's not a gas, but a supercritical fluid, liquid CO2. On our planet, the only naturally occurring source is in the high-temperature, high-pressure environments of undersea volcanoes. The Soviet Venera landers sent back pictures showing that Venus is a vast garden of rock, with no water in sight. In fact, if you were to smooth out the surface of Venus, all the water in the atmosphere would be just 3 centimeters deep. Compare that to Earth, where the oceans would form a layer 3 kilometers deep. If you could land on Venus, you'd be treated to tranquil vistas and sunset skies painted in orange hues. The winds are light, only a few miles per hour, but the air is so thick that a breeze would knock you over. Look up and you'd see fast-moving clouds streaking around the planet at 300 kilometers per hour. These clouds form a dense high-altitude layer from 45 to 66 kilometers above the surface. The clouds are so dense and reflective that Venus absorbs much less solar energy than Earth, even though it's 30% closer to the Sun. These clouds curve around into a pair of immense planetary hurricanes as the air spirals down into the cooler polar regions. Along the equator, they rise in powerful storms, unleashing bolts of lightning. Just like Earth, these storms produce rain, only it's acid rain that evaporates before it hits the ground. At higher elevations, a fine mist forms, not of water, but of the rare metal tellurium and iron pyrites, known as fool's gold. It can form a metallic frost, like snowflakes in hell. Scientists have identified around 1,700 major volcanic centers on Venus, ranging from lava domes and strange features called arachnoids or coronae, to giant volcanic summits. The planet is peppered with volcanoes, perhaps in the millions, distributed randomly on its surface. Venus is run through with huge cuts thousands of kilometers long, that may well be lava channels. Our sister planet is a volcanic paradise in a solar system shaped by volcanism. The largest mountain on Earth, Hawaii's Mauna Kea volcano, measures 32,000 feet from seafloor to summit. Rising almost 3 times higher is the mother of all volcanoes, Olympus Mons on Mars. Jupiter's moon Io is bleeding lava. It's produced deep underground by the friction of rock on rock, caused by the gravitational pull of its mother planet. Then there's Neptune's moon Triton, with crystals of nitrogen ice shooting some 10 kilometers above the surface. Saturn's moon Titan, with frozen liquid methane and ammonia oozing into lakes and swamps. On our planet, volcanoes commonly form at the margins of continents and oceans. Here, the vast slabs of rock that underlie the oceans push beneath those that bear the continents. Deep underground, magma mixes with water, and the rising pressure forces it up in explosive eruptions. On Venus, the scene is very different. In the high-density atmosphere, volcanoes are more likely to ooze and splatter, sending rivers of lava flowing down onto the lowlands. They resemble volcanoes that form at hotspots like the Hawaiian Islands. There, plumes of magma rise up from deep within the Earth, releasing the pressure in a stream of eruptions. To see a typical large volcano on Venus, go to Sappas Mons, at 400 kilometers across and 1.5 kilometers high. The mountain was likely built through eruptions at its summit, but as magma reached up from below, it began to drain out through subsurface tubes or cracks that formed a web of channels leading onto the surrounding terrain. Is Venus, like Earth, still volcanically active? Finding the answer is a major goal of the Venus Express mission, launched in 2005 by the European Space Agency. Armed with a new generation of high-tech sensors, it peered through the clouds. Recording the infrared light given off by several large mountains, it found that the summits are brighter than the surrounding basins. That's probably because they had not been subject to as much weather in this corrosive environment. This means that they would have erupted sometime within the last few 100,000 years. If these volcanoes are active now, it's because they are part of a deeper process that shapes our planet as well. On Earth, the release of heat from radioactive decay deep in its mantle is what drives the motion of oceanic and continental plates. It's dependent on erosion and other processes associated with water. With no water on Venus, the planet's internal heat builds to extreme levels, then escapes in outbreaks of volcanism that may be global in scope. This may explain why fewer than 1,000 impact craters have been found on Venus. Anything older than about 500 million years has literally been paved over. So why did Venus diverge so radically from Earth when it was born in the same solar system and under similar circumstances? There is growing evidence, still circumstantial, that Venus may in fact have had a wetter, more Earth-like past. One of the most startling findings of the early Venus missions was the presence of deuterium, a form of hydrogen, in Venus' upper atmosphere. It forms when ultraviolet sunlight breaks apart water molecules. Additional evidence recently came to light. Venus Express trained its infrared sensors on the planet's night side to look at how the terrain emits the energy captured in the heat of the day. This picture is a composite of over 1,000 individual images of Venus' southern hemisphere. Higher elevation areas, shown in blue, emit less heat than the surrounding basins. That supports a hypothesis that these areas are made not of lava, but of granite. On Earth, granite forms in volcanoes when magma mixes with water. If there's granite on Venus, then there may well have been water. If Earth and Venus emerged together as twin blue marbles, then at some point the two worlds parted company. Earth developed ways to moderate its climate, in part by removing carbon dioxide, a greenhouse gas, from its atmosphere. Plants, for one, absorb CO2 and release oxygen in photosynthesis. 1 square kilometer of tropical jungle, for example, can take in several hundred tons of CO2 in just a year. That's nothing compared to the oceans. In a year's time, according to one recent study, just 1 square kilometer of ocean can absorb 41 million tons of CO2. Earth takes in its own share of CO2. When rainfall interacts with rocks, a chemical reaction known as weathering converts atmospheric CO2 to carbonate compounds. Runoff from the land washes it into rivers and the seas, where they settle into ocean sediments. With little water and no oceans, Venus has no good way to remove CO2 from its atmosphere. Instead, with volcanic eruptions adding more and more CO2 to the atmosphere, it has trapped more and more of the sun's heat in a runaway greenhouse effect. Venus is so hot that liquid water simply cannot survive on the surface. Nor, it seems, can it last in the upper atmosphere. The culprit is the sun. The outer reaches of its atmosphere, the corona, is made up of plasma heated to over 1,000,000 degrees Celsius. From this region, the sun sends a steady stream of charged particles racing out into the solar system. The solar wind reaches its peak in the wake of great looping eruptions on the surface of the sun, called coronal mass ejections. The blast wave sweeps by Venus. Then heads out toward Earth. Our planet is fortified against the solar blast. Plumes of hot magma rise and fall in Earth's core as it spins, generating a magnetic field that extends far out into space. It acts as a shield, deflecting the solar wind and causing it to flow past. It's this protective bubble that Venus lacks. Venus Express found that these solar winds are steadily stripping off lighter molecules of hydrogen and oxygen. They escape the planet on the night side, then ride solar breezes on out into space. All this may be due to Venus' size, 80% that of Earth. This prevents the formation of a solid iron core, and with it the rising and falling plumes that generate a strong magnetic field. There may be another reason, too, according to a theory about the planet's early years. A young planet Venus encountered one or more planet-sized objects in violent collisions. The force of these impacts slowed its rotation to a crawl and reversed it, reducing the chances that a magnetic field could take hold. This theory may have a surprising bearing on Earth's own history. Scientists believe the Sun was not always as hot as it is. In fact, going back several billion years, it was cool enough that Earth should have been frozen over. Because it was not, this is known as the faint young sun paradox. Earth's salvation may well be linked to Venus's fate. The idea is that the Earth occupied an orbit closer to the Sun, allowing it to capture more heat. The gravity of two smaller planets with unstable orbits would have gradually pushed it out to its present orbit. The pair would eventually come together, merging to form the Venus we know. As dead as Venus is today, it has brought surprising dividends in the search for life. On its recent crossing between Earth and the Sun, astronomers were out in force, in remote locations where the viewing was optimal, such as the Svalbard Islands north of Norway. The data gathered here would be added to that collected by solar telescopes on the ground and in space. The object for most was to experience a spectacle that will not occur again till the year 2117. It was also to capture sunlight passing through Venus' atmosphere. Today, the Kepler Space Telescope is searching for planets around distant stars by detecting dips in their light as a planet passes in front. Telescopes in the future may be able to analyze the light of the planet itself. If elements such as carbon or oxygen are detected, then these worlds may well be Earth-like. Venus provides a benchmark and some valuable perspective. So what can we glean from the evolution of planet Venus? As we continue to scan the cosmic horizons, the story of Venus will stand as a stark reminder. It takes more than just the right size, composition, and distance from the parent star for a planet to become truly Earth-like. No matter how promising a planet may be, there are myriad forces out there that can radically alter its course. For here was a world, Venus, poised perhaps on the brink of a glorious future. But bad luck passed its way. Now we can only imagine what might have become of Earth's sister planet.